Day to all of you. Welcome to Haystack Live. My name's Charlie Hull. I'm a managing consultant at Open Source Connections. We're the search and relevance people. And we've got a great talk for you today. A couple of house rules for you. If you could all mute your microphones, that would be great to prevent any background noise. When we come to the end of our talk, we're going to invite questions for our presenter. And at that point, if you could put your questions into the Zoom chat, and then I will select the questions and ask them on your behalf. I may ask you to participate as well if it works out. We are recording this meetup and it will be available on OSC's YouTube channel basically as soon as I can get it up there. So within a day of the end of the talk. And I think Dipak, you'll also be able to provide your slides. So you should be able to pass it on to colleagues. We run these meetups every 3 or 4 weeks. We've got some fantastic ones coming up this year. It's a spin-off of our Haystack conference, which we're also hoping to run in some shape or form this year, which will be great. A few other things for your notice here. We have our training courses running in April and May now. These are Think Like a Relevance Engineer for Elasticsearch and Solr, 2 different versions, and Learning to Rank. And the ticket sales for those are open. And I will warn you, if you are interested, do get in there quickly. Our previous courses did sell out. So without further ado, I'm going to welcome our presenter today, Dipak Parmar, who's going to be talking about query understanding. And Dipak, do you want to introduce yourself? And please, off you go.
Yeah, sounds good. Thank you, Charlie. Hi, everyone. Let me go ahead and share my screen. All right. So I hope you can see the screen now, right? OK, awesome. All right, so yeah, myself, Dipak Parmar. I'm working as a principal engineer at Shipt. And I have been working in the search area for the past 7 to 8 years out of 15 years of my career. And today we are going to talk about search relevance engineering, right? Focusing more on the query understanding and ranking part. So today, we will start with the introduction about the Shipt, what we do, and then we'll talk about different components involved in building out the search relevancy. And we'll also talk about search platform at Shipt, right? So we'll talk about the technology stack that we have here and the indexing pipeline, the search services, some of the Elasticsearch clusters, and lessons learned and best practices, which is also an interesting topic. And of course, we'll have Q&A after that. And yeah, should take about like 40 minutes. And most of these are kind of pretty general topic, right? We may not even go too much detail into any of this, but it should give like an overall picture of, how do we build the overall search platform in terms of powering the great relevancy, as well as building out the microservices and how those things can work together, right? All right, so let's get started. So about Shipt, right? Shipt is a grocery delivery company. It was launched in 2014 in Birmingham. And it's a grocery delivery company, meaning, we have 400,000 shoppers. They shop the groceries and deliver at your doorstep. We have more than 100 retailers and 5,000 plus cities are covered. And, majority of the retailers are grocery stores like Meijer, Target, of course, and, H-E-B and so many other grocery kind of retailers in US. And we are going beyond groceries, right? So we also support many other non-grocery retailers like Bed Bath Beyond, Best Buy, CVS, and many others. And each of these retailers have got different store locations across US, right? So we kind of get the feed and we have to maintain their products data, and we support the same-day delivery for them, right? Which can be delivered in just like a couple of hours. So let's talk about search at Shipt. Like I said, each of those retailers can have multiple store locations, right? So we have to support those kind of inventory, the catalog, and also the search overall. In general, our search platform is driving many features in the site that includes the core search, some of the browse features, special requests, auto suggestions, and in general, like 50% of our searches come from just the top 1,000 unique searches, right? So you can imagine that uh, people just buy the same thing again and again, right? So we pretty much heavily focus on our top tail of the search keywords. And 30% of our purchases are repeat buys, right? So what that means is that we give pretty much importance to what user bought earlier, right? And making sure that we boost those products up based on their purchase behavior. Uh, and in terms of search keywords distribution, 20% are single token, right? Like milk, eggs. 50% are two tokens, and 30% are 3+ tokens, right? So we kind of focus too much on our like single and two tokens. And then of course we have like a long tail as well, as we have more and more tokens. So in general, these are the high level different components of the search relevancy, right? And all of these are kind of applied to any search engine, whether it's like Solar or Elasticsearch, right? In Shipt, we do use Elasticsearch, but these are the concepts that can be applied to any search engine. Pretty standard, right? Like text analysis, right? We have like tokenizers, analyzers, query intent and classification. So that's a pretty key component there, right? Because by intent, we want to make sure that we identify the intent of the search query, the user's intent, what they're looking for, and accordingly, it is important to kind of build the query, which is part of query builder process. And it involves like, we can also have like multiple phases of the ranking, right? So we're going to talk about it more on this, on at least in the Shipt, like how we build all these components, right? So we'll have like some discussion on this as well. So let's discuss about text analysis and query understanding. Pretty much standard example here, nothing new. Probably if you are in search field, I think it's kind of pretty standard thing here. Example, the quick brown foxes jumped over the dog, right? So we want to make sure that we apply the right analyzers, right? Like lowercase and making sure we have the synonyms, like quick is like fast, right? Jumped becomes jump. Removing the special characters, stop words like the can be ignored, right? Engrams, right? This can be used in driving the auto suggestion. So these are pretty standard stuff, but this is pretty important, in terms of overall relevancy, because that's where the things get started. As we ingest the data, we want to make sure we tokenize the keywords in a right way. Some more examples here, right? Like strawberry ice cream, right? Now here, ice cream could be searched with space or without space, right? So what we do here in Shipt is like we also generate the shingles, right? So ice cream can be kind of paired together, right? So we generate those shingles and we also concatenate those shingles, right? So in that way, we build the word pairs. So in that way, if somebody is searching for ice cream with space or without space, it can be kind of, we make sure that we return the similar results for both the cases, right? So this kind of analyzers plays pretty critical role in the relevancy. So let's talk about like query understanding, right? Now this is a pretty big topic, right? But just to get started on this, as per the Wikipedia, it says that the query understanding is the process of inferring the intent of a search engine user by extracting the semantic meaning from the searcher's keyword. And it generally happens before search engine retrieves and ranks the result, right? So before even we build the query for the search engine, that's where the query understanding piece goes, right? Which is outside the search engine. Now, there are some examples here, right? In a grocery world, let's say people search for egg-free bread, for example. So here, bread is an entity, the main search entity, and there's some dietary preference like no egg, right? So it's important to, again, it could be searched with like no egg bread or eggless bread, So it's important to kind of identify the intent it also involves query expansion as well, right? So sometimes we might even want to expand the keywords that they are searching for, right? Like produce could be expanded to even more, it's sub-tree, right? And classification, right? That's also something that can be done as a part of the query understanding. Like if the user is searching for a specific brand, like let's say Kraft cheese, right? So Kraft is the name of the brand, right? So it's important to classify different tokens, and we can build like different classifiers for identifying the intent of different tokens that we have in the given search keyword. And then that's what comes after that, which is a query builder part, right? So once we identify the intent, like in Elasticsearch, we use must match, right? That bread has to be matched. And then if the intent is like no eggs, then of course we have to kind of tweak our query that it should not contain eggs, right? Must not query. So this is like pretty preliminary thing about the query understanding, and the query which is generated as a part of query builder goes to the search engine. Here, in fact, some more examples, right? In a grocery world, like Good and Gather Veggie Pizza. So here, Good and Gather is the brand, veggie is a dietary preference, and the main entity that user is searching for is pizza. Same thing for some of the size related attributes like 1 gallon, 2% milk, right? So 1 gallon is a size and 2% is the modifier, milk is the main entity. Same for the sour cream. Now here, sour cream can be treated as a compound word, right? So it's important to identify the intent that there could be certain keywords which should be treated as like compound word. It should be searched as a phrase match, right? Same for the coffee pods, right? They are not looking for coffee, but it's a coffee pod, which is like one word that they are looking for. Like another example is like peanut butter, right? They're not looking for butter. It's like a peanut butter is like a very specific thing that they are looking for, right? But if it is like a salty butter, salty is more of a modifier, right? And butter is the main entity. And some more examples here, like red, onion, fresh, so onion is the entity, the red is the modifier, and fresh is kind of something that can be ignored. It also depends on the overall catalog structure, but sometimes some of the tokens can be ignored in the search. So how do we kind of build these things together, right? As far as the query understanding goes in general. Like in Shipt, right? We detect the intent, which includes size, brands, nutrition, or dietary keywords, right? We also kind of try to identify color pattern, right? Like red potatoes, red is kind of like a color, right? Pattern, modifiers, and flavors or taste or the shape of the product, right? Like a spicy pizza, right? So that's one of the more kind of like a test. And we also try to detect like negative intent, like we discussed earlier, egg-free pizza, right? There could be some optional tokens, which could be like any stop words or any kind of like, let's say hot coffee. Right now, user is really searching for coffee for the search engine perspective. Hot can be kind of ignored. But if it is hot dog, hot cannot be ignored, right? Because hot dog is a single compound words, right? And we can also, we also do like replacement, query expansions, synonyms, and hypernyms, right? Replacements mainly for making sure, some of the spell corrections that happens, right? Broccoli, like users, most of the time user misspell the spelling for broccoli, right? So it's important to have the replacement, the fuzzy searches, some of the linguistic thing that really is important here. And that can be like NLP techniques can be applied as well, right? So here, like there are like, how do we do all this thing, right? Like, the best way is kind of start with what we have in our catalog itself, right? So at least we know that what are the sizes that we have, right? What are the brands that we have in our catalog? So we can easily build this kind of thing. We can easily build the knowledge base, right? Knowledge database from some of the tokens that we already have in our catalog. And there are some NLP techniques can also be applied, right? So we are also, in fact, working on some of the NLP techniques. It's a preliminary stage right now, but We can also do some of the clustering classifications models that can be applied here in terms of, kind of, we have a huge set of data, huge set of keywords which are being searched, right? So applying some of those techniques like clustering algorithms and models that can be applied here to identify the intent of the query. And of course, there are some other, advanced NLP techniques as well, where we can also think about building using some of the existing models to generate the vectors, right? And using that in our search, right? Which can also be used to find some of the similarity between different products, right? So those are the things that can be applied, and we are kind of continuously working in this area as well. The next thing is about query building part, right? So once we identify the query intent and once we segment the tokens, right, what it means, now comes how do we build the query here, right? So in this example, hazelnut coffee creamer. So coffee creamer is like I said, is like a compound word, right? So it should be kind of, it can be searched as like a exact match, like a kind of a phrase match, right? Partial matches. So sometime partial match criteria can also be driven by the intent, right? So like what we do here is, depending on the intent that we identify, we come out with the best minimum match criteria, right? It can also be driven by the number of tokens that we have sometime. Let's say the main search entity is cheese, but there could be like so much other modifiers, string cheese or certain brand of the cheese. But the main entity is, of course, is must match, right? So this kind of must match, should match, phrase match, all these things can be driven by the query intent. Word drop is a pretty big topic there. In fact, we did like multiple A/B tests in validating like how the word drop is performing, right? Because sometimes partial matches can lead to pretty high recall, right? So we want to make sure that we don't start displaying too much, products. And sometimes we can also do filtering based on the intent, right? So if user is looking for, let's say, a specific type of the cheese or specific brand of the cheese, like say Kraft cheese as an example, right? So we can think about applying the filter automatically as soon as they search, right? So that we kind of avoid the recall. And of course, we can also do boosting, right? Like in Shipt, we have our own rule engine for the boosting, right? So what we do is we have our own rule engine for boosting some of the seasonal stuff, right? That for certain keywords and for the certain time of the year, certain products can be boosted, right? Or it could also be kind of pretty generic, without any timing, we can also boost it for certain keywords to boost some of the categories or brands, right? So these are some of the things to consider in the query building part based on the intent. And then the last thing is the ranking based on what we identify, right? So let's just talk about the ranking part here. So far we talked about, how do we build the query, which is going to drive our BM25 score, right? And at least in Shipt, we do 5 phases of the ranking, right? Because all the phases contributes to the overall score and how we render the products. So first is, of course, our base query ranking, right? Which is purely based on the query intent, our BM25 score, right? Based on the intent, we run the base query and we get the score. The next here is the boosting, right? So we talked about some of the boosting that can be applied. Like I said, we use seasonal boosting, and to some extent, we also do some of the specific boosting for the branded categories. Now, once we get those results, right, the third thing here, the third phase of the ranking could be to come out with even customized ranking with some other signals that can be used. Now, consider, for example, let's say if we search for yogurt or milk, right? There could be like thousands of products that can just get written, right? Now, search engine is more of like a similar text-based similarity model, right? So now there could be like thousands of products, and now how do we rank those products, right? So that's how we can use some other external signals, which could be based on the popularity or some of the geographical trend, right? And those kind of signals can be applied in like in Elasticsearch, we can apply in script score, or we can also think about custom plugin, right? Which can apply some of the customized ranking with other signals. We're going to talk about it more. But the next phase here is once we get the result, like of course in both Solar and Elasticsearch, right, we can also re-rank the top X documents. So now this can be based on LTR or vector similarity or even some other signals, right? We are still trying to figure out like if LTR can play a pretty important role here in terms of re-ranking the top X documents, right? We are still kind of working on that area, but there are options to kind of re-rank at this phase just the top X number of documents by considering some of this in our overall ranking. Now the last phase could be the post-process ranking, right? Which can happen completely outside the search engine, right? So think about once we get, let's say, top 100 results from the search engine, right? It could be possible that we can just kind of re-rank those top based on some more factors, right? Which can happen outside the search engine, right? Like in our case, we have our own separate microservice, which takes care of re-ranking the top X documents, right? And like I said, our 30% of the purchases are repeat buys, right? So what we do is we kind of, again, re-rank and at least boost the products which user already purchased before, right? More of like a personalization factor. So, and like if you go to like shipt.com and search for, any products, and if you purchase those products already, we kind of boost those products and move it to the first 2 slots. We have some rules around, which slots can be occupied, because first slots are pretty important, right? Customers always see that, and most of our conversion happens in like first row. So it's pretty important to kind of making sure that we boost those products, which is more relevant to the user based on their purchase history and probably some other personalization factor as well. So we talked about like phase 1 and 2, kind of the base query and the boosting earlier. Now let's just talk about like how this customized ranking can be done, right? So here is one example, right? So let's say if we ingest some of the popularity scores at the product level, right? So that's one way to go, where we can have some kind of like an offline process to index the popularity score at the product level. And we can also think about indexing some of the neighborhood or the geographical trends that could be happening in a specific region, right? So those kind of things can also be indexed and can be considered in the ranking. And we can also think about product to converted keywords mapping, right? Now here is just one example where for the given product, let's say this is the product, Good and Gather mozzarella string cheese, right? Now this particular product was converted the most if users search for string cheese, right? And this is some kind of like a ranking score, right? That can be derived based on the past conversion, based on where it converted and things like that. But basically the idea here is to maintain that kind of a score at the keyword level for different documents, right? So here this product was converted for string cheese when they search for string cheese or cheese stick, right? But this product didn't perform pretty well when they search for, let's say, mozzarella or just the cheese, right? So it's important to kind of, we can think about tracking this. There are certain like disadvantages as well, but at least for us, it performed pretty well, where we track how the product is performing, at the keyword level and maintaining some kind of a score. And that can be used in our overall ranking, right? So like in our case, in Elasticsearch, we use Painless script, which is a scripting language, right? Which gives a lot of flexibility in terms of how we score the documents. And so we have our own ranker, which is taking different signals, including BM25 score. And it can look something like this. The final score could be the BM25 score into some weight, plus signal 1 into multiplier if required into weight, plus signal 2 into multiplier into weight, right? So this kind of equations can be derived for overall ranking. And sometimes if any of the signals are kind of pretty high, logarithmic, and some of those formula can also be applied here. Uh, and multiplier is also something that can be applied if we feel that this is kind of not aligned with overall score that we receive, right? Uh, and there are of course certain challenges, with this approach where, the most number one challenge here is how do we come out with these values, right? So and simple answer is, it's something we have to kind of give it a try, A/B test, right? We did like multiple A/B tests to come out with different weights, right? And like sometime, this weights value can also be rule based, right? Like if the product, if the store is performing, it's pretty high, it's pretty good, has been launched for like long time, that means it will have pretty good popularity already built, right? So in that case, it makes sense to kind of give little more higher weightage to some other factors compared to beyond 25 score. Uh, and then, in certain cases, if it's a new store, new products, I think we should have a little higher weightage for the beyond 25 score. But I think it's pretty challenging. I think what is important here is to do some kind of like A/B test. And it's important to kind of see what's the overall score that we get, right? We cannot kind of normalize the value we cannot normalize the BM25 score, as we all know, right? But overall, based on like max value in general, the average score that we get, based on that, these values can be relatively applied, right? It just needs some more test and some A/B test. At least for us, it performed better. The system was able to learn by itself, right? Because we keep updating those signals regularly, right? So it just learns by itself. And think about like initially, if you search for something and the relevant product is on the fifth row, right? But as people search more and more and they add more and more to the cart, it automatically comes to the top, right? So this is like another way to just kind of build a system which can learn by itself in our base ranking, as part of like our, and then the next phase could be even re-ranking this based on some other criteria like LTR or vector similarity or some other signals as well, right? So those kind of things can be designed. Awesome. So we are at the last section of the presentation, which is search platform, right? Like how do we build at the Shipt, how we build the system, right? Here are the technologies that we use for the search platform, right? We develop all of our services in Go language, right? So we have our workers and services built in Go. And of course, we use Elasticsearch. We also use Redis and Postgres, right? Those are some of the data stores that we use to store some of the signals and doing some of the offline processing for the search related task. And we also use Kafka. We use some standard stuff, Docker, Kubernetes, Rollbar, Grafana, and our Elasticsearch is hosted in Elastic Cloud. Here is the overall, diagram in terms of indexing pipeline, right? So what we have is we have a separate pipeline for the products. We get the products, and we develop our own worker in Go, which is listening those product events, and it gets indexed into Elasticsearch along with some more data that we have in Redis here, right? Now, what we do here is, like I said, we also index signals, different signals that we use in our ranking. So we generate this kind of signals in our separate worker, and everything is like developed in Go, right? And those get stored in Redis, and then as soon as the product comes, product update comes, it just gets indexed along with those, the latest signals score that we have in Elasticsearch. And these are kind of all real time, right? So there is no bad jobs. It just gets indexed as soon as the product updates are happening there. And we also have purchase history as a separate cluster, right? So what we do is we listen to the cart events, and we have our own purchase history worker, which is kind of putting all the purchase history of the user. And we are still working on this part, which is building out some kind of like search intent worker or the query understanding worker, right? Which would be, developing those different intent classifications We have this logic right now in a separate service, but we are kind of, trying to have its own worker which can take care of this, and planning to put that into its own cluster. And in future, we are also planning to kind of automate the synonym process where we can directly push our synonyms into Elasticsearch. So that's something that we are also planning. Here is the diagram for overall search related services that we have at Shipt. So the major service here is the Elasticsearch API, um, which which in turn calls some other APIs like data mapping, right, which stores some of our static mappings, and it also stores some of the rules around seasonal boost, right? We also call synonym API. We have like completely separate API for that, which gets some of the replacement, expansion, and things like that, right? And of course, once we have this service ready, we are planning to call that. But right now, some of the intent stuff is happening within the Elasticsearch API. And like I said, we are kind of trying to segregate those logic into its own API. And we have like two chains of API here for the search, right? So we also have another layer here, search API, right? Which is doing its own ranking. So once it gets the products from Elasticsearch, right, we also call purchase history API to make sure that we boost, kind of re-rank those top X products based on the user's purchase history, and kind of even boost it to the top 2 slots, which is the most highly demanding slots for the search, right? And of course, it also calls many other services, which is not depicted here, but in general, it tries to get details, coupons, pricing, and things like that. We also have our own experimentation platform, right? So it's like in-house platform that we built, and we have our own API for the experimentation to do A/B test. Any search relevancy changes always goes through the A/B test process, right? So we basically, we have this platform which can divide the customers based on the traffic that we specify, and those things kind of driving some of the changes that we make, right? So that's something that we built in-house there. All right, what next? So we have, our application is pretty write heavy, right? Indexing pipeline is pretty write heavy. And we created like multiple groups of clusters based on different criterias like search traffic. Certain stores, we get pretty high traffic compared to others. Indexing traffic, right? Certain stores have like more indexing traffic compared to the search traffic, right? And then of course the number of documents, the size of the documents that we have for the store, right? So we create like different groups of the cluster, and of course we have like multiple replicas, and mainly in a single query we try to get everything including aggregations, and about p99 of about 70 milliseconds. Let's see. All right, so this is my last slide here, pretty interesting. So some of the lessons learned and best practices, in our experience. Pretty standard, right? Single responsibility principle, right? It's a pretty standard principle. Don't do too many things in one microservice, right? Like I said, we were doing too many things in like one microservice for the Elasticsearch, right? So we are trying to separate out some of the query understanding logic in its own microservice. So that's important. And then related to that is separation of the concerns, right? It's important to kind of uh, separate out the logic, modularize it, and reuse that, and avoid the duplicate logic. Pretty standard thing, but in our experience, it's pretty important, especially for the search platform, because sometimes we get all the product details, and sometimes we have seen that some of the logic is kind of duplicated in some of the other services as well, right? So it's important to just kind of modularize. Like in Go, we can just develop a Go module, right? And it can be imported in other microservices. Let's say, don't try to solve everything with search engine, right? Like we all know search engine is great, but it's still doing textual similarity, right? Majority of our score is kind of driven by how it is matching with the documents, right? So I don't think we can solve everything with search engine, right? So we have to go outside the search engine sometime and take care of the stuff like intent, query understanding, that can be completely done outside the search engine. Uh, and in fact, that's the next thing, like don't try to solve everything with machine learning, right? So that also we found that, uh, machine learning is great, in terms of coming out with some of the predictions for the different signals or coming out with some of the clusterings or models, right? Or even some of the query understanding part, right? So those are all great things for the machine learning. But when it comes to textual similarity, of course, search engine can sometimes do the same thing pretty quickly without less effort, right? Machine learning sometimes takes a lot of time to develop and iterate. So it's important to kind of come out with the things that can be done and with the search engine or the machine learning. We also did recommendation and perform pretty better with search engine, compared to using some of the models in machine learning for the recommendation for those similarity stuff. Awesome. The next thing about like Elasticsearch related stuff, right? What we found is that high refresh interval setting in Elasticsearch can improve the response time P99. Especially if you have like very write heavy application. Um, what happens is that I think by default every 1 second it tries to commit or refresh the indexes, right? And if you have too much writes and too much read at the same time, it can potentially degrade the P99 for the read, right? And what we did was we just increased that refresh interval to some high value, like 30 seconds or even 60 seconds. And so it improved the read response time. We were okay to delay the updates by 60 seconds, and overall it performed pretty well in terms of performance. Start with optimizing the head keywords, right? Followed by torso and tail. Especially for us, our majority of our keywords are from head and torso, right? So we focus too much on the head and torso, and we focus too much on the ranking stuff, right? Like I said, if you search for like milk, there could be like thousands of milk product, right? How do we rank those things? And those are some of the repeated searches, like 30% of our searches are repeat searches, right? So it's important to kind of, go step by step. The next thing here is act fast, evaluate fast, right? Learn from A/B tests, fail fast. At Shipt, we act pretty fast, in terms of like when it comes to relevancy changes, right? We just test it out. We have our own A/B test. We apply the changes. We just monitor those changes, how it performs. If there is any negative impact or anything like that, we just kind of reiterate. We come back and we just kind of do the same thing. Like for word drop, I remember we had like multiple A/B tests, right? Just to make sure that we are kind of not uh, kind of impacting anything. With the word drop or the partial matches, it was like conversion remains almost the same, but it just kind of improves the overall experience for the user. Parent-child relationship in Elasticsearch could degrade the performance, depending on the use case. So what we found is we were trying to explore different cases there in terms of how we store the product to items, right? Product to SKUs combinations. And in fact, for us, we also have like retailer to different store locations, right? Some of the information are at the product level, but some of them could be changing at the store level, like prices or an inventory. So based on our load test and based on our different combination of the tests that we did, parent-child relation sometimes could degrade the performance. There are advantages for sure, like it simplifies the queries sometimes, right? In terms of applying the filters like color and size, it simplifies the things, but we just need to keep an eye on performance as well. And in fact, related here is duplication of data is just fine in most cases in the search engine based on our experience here, right? So even if we kind of duplicate the data sometime in the document, it sometimes just performs fine. It might even simplify the things, right? So there are again trade-offs. Again, not in all cases it could be a better choice, but again, there are certain, of course, there's some trade-offs in terms of either you duplicate the data or kind of normalize the data, or use some kind of like nested structure or parent-child. At last, excessive use of fuzzy search could lead to performance overhead based on our experience, right? So what that means is uh, when we're doing some load tests, we're just kind of applying fuzzy search for all the queries, right? And then what we did was we kind of avoided the fuzzy search if the keyword is already correctly spelled. Now we need to have some mechanism to identify that. That could be a separate, service. But if it is already correctly spelled, no need to kind of apply the fuzzy search, and it could help in performance. And this is what we found based on our experience with version 6.8 in Elasticsearch. So it improved our performance once we, avoided those things. Awesome. I think that's pretty much it. And hope you guys enjoyed it. It was helpful, and happy to take any questions.
Fantastic. Thank you so much there, Dipak. That's been great. I'm going to just see if we could got some questions from the floor. Lovely, actually, just to mention, thank you for some really good practical tips there as well. And it's always refreshing when somebody shows us how things actually work, how you set everything up. So that was very refreshing. So I'm going to go through the chat now. We've got some questions here. So Atita asks, is the calculation of popularity derived by order volume? Do you also have sponsored results? And how do you take into account balancing popularity and sponsored results?
That's a good question. So in our case, we do have some of the featured products, right? So those are not really the sponsored product, but those are more like featured products that we work with some other vendors as well. But overall, like I said, those kind of things can be done in the last phase, right? Like in our case, we have our search API, right? So once we get the top, let's say 100 products from Elasticsearch, just the product IDs, right? There could be a service which can even re-rank those top products, and some algorithms can be applied right over there, right? Which could count the sponsored products or buy again products, or some of the personalization factor for the user, right? So that can be done outside the search engine in the last phase of ranking. But of course, there are some ways to do that. If you want to maintain your own cluster just for the user level personalization info, right? But yeah, for us, yeah, we do it in our own service separately.
Okay, thank you. So I'm going to ask the next question here. I do apologize in advance for any terrible pronunciation of your names. Abhilash asks, how do you normalize the scores generated by Elasticsearch? I see applying boosts, weights, functions, and function scores. The score can be any number.
That's true, and it's pretty challenging. I don't think we can normalize a score, first of all, right? So we have to kind of, in fact, when I was working on that, right, I remember I tried to even normalize a score, right? But for that, we have to know the max value in the script score itself. And there was no way to even get the max score from the script value, right? Because at that stage, it is still kind of ranking the documents, right? So I'm not sure it would be possible in the later version of the Elasticsearch, but it was pretty hard to kind of normalize a score. So what we end up was kind of just adding or adjusting the existing score and adding some other signals on top of it. And like I said, it's challenging. I know, we just need to kind of do some more A/B tests to find out the best combination, right? It's hard to figure out whether the textual scores should be, let's say, same as it is, or we should kind of reduce it by 90%, right? And add some more other signals, right? But if we know the overall average of the score, like in general, of our scores are kind of changing from 1,000 to, let's say, 3,000 or 5,000 in general, right? Textual relevancy BM25 score, right? So I think it can give some hints right over there to kind of use some other signals relative to that value.
Okay, so you're effectively looking at the range of scores you're getting back and then using that as a basis for a kind of normalization.
That's right, yeah.
Fantastic. Jakob asks, how do you do pagination if you're reordering results post the search phase?
pagination, so basically, yeah, I mean, like an Elasticsearch, right? We have the start and the page number to be requested, right? So we just kind of use the pagination in terms of, the number of documents that we want to display in the page, right? And when you specify the next, I would say, set of the results, like if it is for like 50 products, the next would be 51 to 100, right? So yeah, I mean, that's pretty much what we use. But when it comes to the last phase of the ranking, that is still based on the result set that we retrieved, right? So if it is like first page, we just kind of reorder those, right? And for us, people may not even go to the second page, right? So that's what we focus on, to make sure that we return the results and get user converted right in the first or second row, right? Without even user going into the second page. That's in fact what the goal is.
It's kind of the rule of thumb of search, isn't it? Nobody ever goes to the second page, and if you're lucky, they might read past the third result.
Right, yeah. So we focus too much on our first couple of slots, which is pretty important. We kind of personalize those first couple of slots in terms of what user is looking for.
Fantastic. Okay. Have you experimented with different scoring formulas, asked by Michelle, different weights for different clients or even different queries?
Have I experimented with different? I'm sorry.
Michelle, I don't quite understand the question. If you'd like to unmute yourself and maybe explain a bit, that'd be great.
Yeah, sure. You were showing the scoring function, and you had some weights and signals combined together with the score. And I was wondering if you found out that maybe there's one equation which is cool for one client and maybe another equation, other weights useful for another client. So you would actually use different scoring formulas for different clients. My question was if you experienced this and how did you deal with this?
Yeah, no, that's a great question. In fact, we cannot have one scoring formula for all the cases, right? So in fact, we also did some tests where we tried to change our scoring formula. There were kind of some rules that we came out with to change different weightage based on popularity of the score overall, right, for the store. So let's say there are certain stores which are kind of newly launched, right? So it may not even have any much signals generated, right? So in that case, we just kind of give higher weightage to the textual relevances, BM25 score. But as the stores are progressing, as people are buying more and more stuff for that store, it becomes more and more popular, right? So we also did some POCs to maintain, to generate the store level popularity scores, at the store level, like in terms of how the stores are performing, offline process, and then using those values into our ranking algorithm to kind of adjust those scores based on the stores, I would say the age of the stores, right? Or the products that we have in the store. And one thing I would also say that another way to even adjust the score is based on some of the query understanding stuff, right? We can also think about adjusting those things, right? So let's say for certain keywords like, which are single token or two tokens, milk, yogurt. So we can just give pretty high weightage to other popularity factor compared to the textual relevancy. But if it is a pretty long query, right? Let's say Ben and Jerry caramel organic ice cream, something like that, pretty long query. So in that case, I think BM25 score should be a little more, right? So I think based on number of tokens, the scores can also be adjusted, or based on stores or it's the age of the store or popularity, the overall signals can also be adjusted.
Great. Skipping forward to, Melissa has a question here. Can you tell us a bit about your team? How many people are working on Search at Shipt and in which roles?
Yeah, absolutely. So we have like a couple of folks in the search team, right? We have our other team, which is for data pipeline, but for the search, we are basically a couple of folks in our team, all our search engineers, and we are we also have some of the machine learning experts as well in our team, the data science and machine learning expert in our team as well. And we work together, it's important to kind of, like I said, few things can be solved with search engine, few things can be solved with machine learning, right? So it's important to kind of understand and get the advantage of the both, right? So some of the things we also try to keep as much, try to keep the things outside the search engine as much as possible, right? I mean to say, if there are a few things about the intent, for example, right? So those are completely separate thing, it has to be completely separated out, it's on microservice, and there could be like machine learning folks working on that, right? So that's how we work. But overall, yeah, I mean, we are just kind of a couple of folks, right? Search engineers and machine learning experts, data science experts.
Okay, thank you. I'm going to just modify Luke's question slightly here. Can you give us a couple of successful uses of ML and NLP for query intent classifications from your experience?
Yeah, I mean, we are still beginner, honestly, right? So we are using NLP for some other use cases, but at least for the search intent stuff, we are still kind of, I would say, beginner in terms of applying the NLP, right? We are trying some models to figure out. In fact, there are, for the grocery world, there is like some database also available, for some of the grocery intent. So we are just trying to figure out, we don't have like any specific, I won't be able to tell you any specific, the model name and things like that, but overall, we are kind of still, expanding in that area.
Okay. So here's a question, and this is close to the heart of us at OSC. How do you measure search relevance quality? What sort of tools do you use internally or externally?
Yeah, no, that's a great question. Pretty big topic there. Sorry. So in our case, we measure some couple of factors we count, right? One is the add to carts that happens, right? As soon as user adds to the cart. Another could be a number of search events, right? Some of the changes could lead to more search events, right? So if average number of searches per session is increased, that means we are probably not doing good. In some experiment, if the average number of searches increase, that means probably we are restricting the results and people are not looking for. That's why they are researching the same thing in its next search, right? So we kind of measure that as well. And of course, we also count the conversion rate, pretty standard formula there, right? The search conversion rate to basically, depending on the number of search events happen in the test and number of add to carts that happened in the test, right? So based on that, that's also another factor that we count. But of course, there are certain challenges that we have to kind of consider both A and B, they need to have the similar kind of overlap of the keywords, right? To get more accurate results. And we also track the grid position where the add to carts are happening, right? So we track all these things as soon as user adds to the cart. Let's say, what's the position number from where they added to the cart, right? So we have some measure as well to come out with some kind of like medium index to calculate the medium index of add to carts that happened between control and variant of the experiment and use that. So these are some of the major things that we use, but sometime it could be, we might even look into some other factors based on the test, but in general, these are the things that we use as a part of our A/B test.
Okay, what sort of tools do you use to gather these measures?
These are all completely in-house. We don't use any external tools. So we have our own tracking mechanism, right? So we store it in some in our data store, and we have our own experimentation platform. We have our own way of kind of coming out with this kind of metrics as well. So yeah.
Okay. So Michelle, you've got a fan for your shirt. And Simon asks, and I may actually ask you to ask this question yourself, Simon. I think I sort of understand it. Do you want to try and word it yourself?
So if you have a re-ranker of the search results, it changes the results. And if you improve the base search. So for example, the Elasticsearch fields, you improve the boosting of those fields. The result changes and the re-ranker re-ranks the changed results. So there are two changes in effect. And my question is, how do you test an improvement in the base search algorithm? Do you?
Yeah. Yeah, no, you're right. So like you said, right, one is like a base query where we specify our base query in terms of the fields to be searched on and its weights, right? And another is our ranking, right, which can add some more popularity signals, right? But in terms of validating, at least in our API, we have some, we develop around debugging tool where we specify that if you want any kind of metadata, right, it can return those metadata, whether how much was the original textual score, how much is the signals, different signal values, right? So basically what we do is like total scores that we get minus the signals that we added on top of it, right? That becomes the BM25 score, right? So we have some debugging utilities like that we created. But in terms of measuring, yeah, I mean, if we have to do it locally, you know, we just use the APIs to debug this kind of thing. But you can also kind of A/B test it, right? Like, you know, one flow goes into just the base query, it will not apply the ranking formula. And another test would apply the ranking formula, and you can kind of compare those results as well to see how much benefit it is getting.
Okay.
Yeah, thanks a lot.
So we have a last question here, actually. Florian asks, what's your toolbox to work and iterate and test stuff before going to A/B tests? Do you have a full duplicate development environment? Do you use ground truth and implicit feedback? Do you have experts providing ratings? Do you train end to end?
Yeah, I mean, in terms of validation, it's something that, you know, it's not a like big team. We just validate ourselves, honestly, right? We don't have any formalized process in terms of evaluating the things, right? Like I said, we move pretty fast, right? We just do some validation ourselves in terms of the process. And if we have to test this in production, we can just enable some traffic, you know, let's say 1 or 2% of the traffic in production to validate a particular change, right? And we just kind of evaluate pretty fast. Once we get the data, we can also terminate the experiment ourselves in like a couple of days or a week, right? But we don't have like any formalized process, honestly, in terms of how we evaluate the results. There are ways to do, like we had some kind of utilities created ourselves in terms of extracting the results in terms of like images, right? For let's say control, and the same thing for another experiment B, right? And we can just eyeball those things, but we don't have like any formalized process as such, you know, in terms of using some of the normalized distributed gain and NDCG scores and things like that. That's in fact something that we would like to kind of go to the next step as well in terms of how we use some of those formula as well, you know. So
okay. So you don't have a kind of offline search testing setup. You're going straight to A/B tests.
Yeah, we just do some basic tests. We have some basic utilities available to validate or eyeball some of the things for our top searches, right? Because majority of our searches are repeat searches, right? So like even if you validate like 1,000 searches, that's more than enough, right? Because that is our major searches, unless any changes are going to impact the torso or the tail keywords, right? So that's a different story where we might even look into further. Okay. But in general, yeah, that's how we kind of do some validation ourselves.
Fantastic, thank you. So that's all the questions I have in chat. If anyone's got a last question for Dipak, please do type it in now. It's your last chance. I think that may be it, actually, Dipak, unless somebody is typing furiously as I speak. Wonderful. Well, firstly, I'd like to thank you all, everyone who's asked a question. Thank you, Dipak, so much for coming and sharing everything with us. That's been a really lovely talk. Always nice to hear the practical considerations of how you actually do this stuff, and to hear about your team as well. That's also very interesting. So thank you so much for that. I'm going to just share something very quickly. If I can get this to work. So we have our next Haystack Live meetup will be on March the 11th, and may be of interest to a few people. We've got a wonderful talk from Kyle Davis of AWS, who's going to be talking to us about Open Distro for Elasticsearch and beyond. You may have heard some news about this. It's been occasionally mentioned over the last few weeks. So do come to that. We've got some other talks lined up for afterwards as well. More details to come. And also just to remind you of our training in April and May. If you want to learn to think like a relevance engineer or find out how to learn to rank, then do check that out. Come and join us in Relevance Slack. There's 1,300 people in there now, which is astonishing. And there's over 700 people in this meetup group. So I'm very pleased about that. And we hope to welcome you back to our next Haystack Live, and hopefully before the end of the year, a bigger Haystack experience. But I'll let you know about that when we have better news. So thank you everyone for coming. Thanks again, Dipak, and we will see you all again soon.